So I'm here in New Jersey and it is a beautiful evening. However, about 1,200 miles to my southwest lies Tropical Depression Beryl, which made landfall as a Category 1 hurricane really early this morning, around 3:47 in the morning on the Texas coastline. So let's look at what happened leading up to landfall with Beryl and where it's headed next after what it's been through right now. So, if we look right now at what Beryl is doing, it's a tropical depression right now over East Texas. It's gonna move path more or less like this. This is pretty accurate. There's not really any discrepancy with the models, and it should dissipate sometime tomorrow. It's probably around the morning. And it should lose its tropical characteristics. So we just want to look at what it did before landfall. Let's take a look at what it's doing right here. So there was some dry air that was entrained in the circulation towards the center that was keeping convection from really holding ground. But then around a little bit after OZ, you can see these vertical hot towers that start rotating around the storm. Let's just go back a little bit to watch those. And what these vertical hot towers they actually do, they allow the storm to kind of tap into the vorticity that they provide because these are really high and tall thunderstorms that develop near the center. And usually they're a sign of rapid intensification. So now what actually happened here that kind of made people get lucky in Texas is that this only happened when the storm was really close to making landfall, which led to it only making landfall as a Category 1 hurricane versus what the models were saying. They were saying potentially Category 2 landfall. And if we want to look at why it really wasn't intensifying before, is if we look here, there's a lot of dry air that was like trapped, especially towards the center. And it really wasn't able to intensify until right before landfall. And this is seen from like the HWRF diagnostics. We can see even though really low shear values of 10 and even below knots and high sea surface temperatures approaching 30 degrees Celsius, the dry air really like held it down. Now the HWRF model was actually having it intensify quite strong, but what it was underestimating was the effects of that dry air in there, and that was proved by the storm itself not intensifying as much. Now, if we look at what's really happening with Beryl right now, the main threat is the tornado threat, and the tornadoes today they have been the supercells, the mini supercells out of this thing have been long lived, and they've just been coming in trains. Like look at these three. These three originated down in Louisiana. They're still going strong, heading into Arkansas. And there's just a whole nother train coming with the actual main line. Every single one of these is a mini supercell on this line. Every single one of them is rotating. If we just look at the environment off the HWR, let's just look at what it was in Louisiana today, where some decent tornadoes happened today, pretty strong ones. And look at that photograph, just absolutely massive photograph, massive spike from surface to 850 millibars, massive curvature, 274 SRH in the 0 to 3 kilometer layer, and strong instability as well, 2,200 joules per kilogram at the surface based area. Now we just want to look into the overnight tornado threat. Um, the main threat will be moving into Arkansas now, moving out of Louisiana. And if we just want to look at a sounding over here, look at what the environment's going to continue to be. Yeah, look at that. Absolutely massive rotation potential with our photographs being absolutely massive, big curvature and elongation as well. And the story is going to be the same as it moves into the Mississippi Valley tomorrow. Same thing. Look at these mini supercells over here depicted by the HWRF. Take a sounding over here. Look at what the environment's like. Same thing. Massive photograph, decent instability, textbook mini supercell environment off of tropical cyclones. Now, later this will be moving towards the northeast, but it will start dissipating by then. So we just want to look at what it's projected to do, how it's supposed to progress. It'll be pretty well defined up until about Thursday, and it'll be providing severe weather, especially tornado potential, up through Wednesday. And Thursday is where it's gonna really kind of lose its characteristics. And rainfall wise, it's definitely gonna drop quite a bit of rain on its path, but as it starts to dissipate, especially towards Wednesday, it's not gonna be much. And actually, over here, what happens is this isn't from Beryl in the mid-Atlantic states. This is actually just from a frontal system over here that kind of stalls and a high pressure just steering moisture into this area. So if we want to look at specifically the severe threat in the northeast area, let's just start by looking at what Beryl is just projected to do. Synoptic wise, we can see it's able to maintain its characteristics as a surface low pressure, um, more as a like proper well-defined cyclone up until Tuesday, And Wednesdays where it just starts to become more of a broad low level pressure, and by Thursday it's pretty much just a low pressure that starts to dissipate into Friday. And if we want to look at how far it can maintain its circulation, that kind of starts to lose integrity by the time we get into Wednesday. Uh, Wednesday starts to broaden, and by Thursday, it's pretty much lost integrity. Even Wednesday night, it's lost integrity of its lower level circulation. It's been absorbed by this upper level trough we can see coming from Canada, the 500 millibar heights. That trough kind of just picks it up. And if we go back to the satellite imagery, actually, we can see that happening right now. If you look at this upper quadrant over here, you can see how it's just getting sheared. The outflow is just ventilating up to the north, and that's a result of that trough that is picking it up coming out of Canada. You can see it's dipping down over here, picking it up, and basically by Wednesday and Thursday, it's getting absorbed into that trough itself. So we're already seeing how it's produced severe weather today across Louisiana, Texas, Arkansas, and it's expected to again tomorrow in the Mississippi Valley. Let's just move on to specifically the Northeast, and more so areas towards western Pennsylvania, western New York, those kinds of areas. So let's just look at the NAM 3 kilometer model real quick. Let's see what it kind of depicts over the area. So this is going to be taking place on Wednesday. Surface low pressure sets up over Michigan by morning, and after 18Z we can see storms start to fire along kind of this front that it's bringing with it, and kind of a line of what would be expected to be miniature supercells would fire. And we look at the environment ahead of this, proper photograph out of that textbook, very warm environment with decent instability off of tropical cyclone, really good veering. Look at the storm slinky over here. Look at how much this veers. It almost just makes a full 180-degree turn. And yeah, the photograph won't be as big as it was in prior days, but still pretty big photograph. And this threat should mainly be in this area over here, because after nightfall it's really going to weaken because there's not much instability that's going to be available to these storms. So probably towards the Susquehanna in Pennsylvania and towards Binghamton in New York is as far west as this threat's going to extend. Probably should not be any threat in New Jersey unless some storm can somehow sustain itself past nightfall, which is pretty unlikely considering there will be capping in place. We just want to take a sounding to verify that. We can see that the capping inversion, especially even above 700 millibars capping, surface capping as well, it's going to prevent these storms from really continuing. And especially with these mini supercells with these lower heights, they aren't really able to tap into much instability, and they really depend on low level 0 to 3 kilometer instability. And when that really isn't there for you, especially after nightfall, when this system is dissipating, really won't be providing any severe threat to anyone. So yeah, that's pretty much what Beryl's going to do in the future. It should dissipate by Thursday, as the National Hurricane Center is describing in their graphic. And as per what it's done in Texas so far, I actually have a video from a contact I have near Houston of what it's done. I'll just tag that at the end of this video. But yeah, thanks for watching, guys, and I hope you learned something new.